Hey everybody, today we're going to be taking a look at Address Resolution Protocol. ARP is responsible for resolving an IP address to a MAC address. To be able to send a frame over a network, we must have the destination MAC address. Here in our example, PC1 is going to try and talk to PC3. The first thing it will see is if PC3 is on the same subnet. If it's not, then ARP will react a bit differently. In this case though, you can see that PC1 and PC3 is in the same subnet. So now PC1 is going to do a few checks. It's going to look and see, okay, I need to talk to 10.1.1.3. And it's going to look in its local ARP cache to see if it may have an entry already for that, which would be 10.1.1.3, and then the CCCC and a bunch more Cs. If it finds that, then it does not need to broadcast. They can immediately start talking to each other. However, if it doesn't find an ARP entry for 10.1.1.3, then it's going to have to broadcast the attempt to find it. Okay, what I mean by that is it's going to send a destination MAC of FFFF.FFFF.FFFF to the switch. It's going to craft a frame with that in the destination MAC. The switch will receive that. When it receives that, it will alert everybody on the local subnet to the fact that 10.1.1.1 is looking for 10.1.1.3. Now, every device on the local subnet will receive this broadcast. Our server here, he's going to see it, as well as PC2. But neither one of these are actually going to do anything with the frame besides realize that, hey, it's not for me, I'm not 10.1.1.3. So they're just going to drop it. However, when PC3 gets it and he says, hey, somebody's looking for 10.1.1.3, that's me, he will simply respond with a unicast, which means he's not going to be sending no broadcast back. He's going to send it straight to PC1 because now he has PC1's MAC address to talk to him. So he's going to say, hey, that's me. PC1's going to say, okay, great, I have 10.1.1.3. I now have your MAC address. Let's talk. And at this point, PC1 adds PC3 into its ARP cache. Now earlier I mentioned that PC1 checked to see if PC3 was in the same subnet. In this example, the PC we want to talk to is PC4, and it's actually in a different subnet. As we know, routers stop broadcasts. Therefore, if we need to talk to a system outside our own subnet, we must use our default gateway. Now most of the time we are going to have an ARP entry for our default gateway from doing just basic tasks such as going to the internet. But if we didn't, the process would be exactly the same, except here our system, instead of issuing an ARP broadcast for the destination IP of 192.168.0.1 for PC4, it would just issue the broadcast for the default gateway 10.1.1.254. So basically, anytime we need to communicate to an IP address that's outside our network, we will just use our gateway MAC address for the destination MAC address. The gateway will handle it from there. So one more thing I would like to go over is the ARP cache itself. To view the ARP cache, you can open up just any command prompt and type in ARP-A, and that will show you a list of all the entries that it has. If you're on a Cisco router, you can do the show IP ARP, and it has a very similar output as well. And here at the end, I basically just got us a summary over exactly what we just talked about from the beginning of the ARP process to the very end. Thanks everybody for watching, and please like and subscribe if you enjoyed this video.